So in this video, we will be going over how to graph quadratic functions from a standard form. So the first question you'll have is, how do you graph a quadratic function from the standard form? First, what you want to do is identify the axis of symmetry. And to recap, axis of symmetry is x equals negative b over 2a. Then, step 2, using the value found in the axis of symmetry, we're going to plug in the x value to the equation to find the vertex. So when you plug in the x value from your axis of symmetry in your function of ax squared plus bx plus c, then you'll be able to find the x value and f of x value, and that is your vertex. Then step 3, using your x value from the vertex, you're going to create a table. So the vertex should be right in the middle. And then you'll subtract 1 and negative 2 from your x value, and you'll add 1 and add 2 to the x value. And by finding those x values, you'll plug it back into the function, and you'll find the y value, and you'll find the coordinates to graph on your graph. Then step 4, once you get all your points, what you're going to do is you're going to graph the 5 points that you obtained by plugging the values in, and you'll graph your quadratic function. And a way to check quickly is by looking at the a value. If a value is greater than 0, meaning it's positive, then your graph should be a U shape going upwards in the upward direction. And if your a value is less than 0, meaning that's negative, then your graph should be going in the downward direction, which is facing down. Now you've read and listened to me explain this, but it's still complete nonsense unless we do the problem together. So we're going to do the example together. This is the example. If you think you have a good handle over this problem, press pause, try it on your own, and then resume the video. But if you have no idea what we went over, then just continue watching and follow along and take notes. So the first thing you want to notice is that this is a quadratic function, and this is in standard form. So standard form means that it's an ax squared plus bx plus c format. So we know our a is negative 2, and writing this out helps. B is 8, and C is negative 5. Now, what is the axis of symmetry? Take a guess. If you said it's x equals negative b over 2a, you are absolutely correct. So find your b value, which is 8, plug it in. You'll get x equals negative 8 divided by 2 times negative 2. That means x equals negative 8 divided by negative 4, which is 2. So our axis of symmetry is x equals 2. Now, how do you find the vertex? In order to find the vertex, what you want to do is you'll use your axis of symmetry, which is x equals 2, and you'll plug it in to the original function. So your function is y equals negative 2x squared plus 8x minus 5. And you are correct if you said plug in the 2 to the x's. So we plug it in, then we'll get y equals negative 2 times 2 squared plus 8 times 2 minus 5. So y equals negative 2 times 4 plus 16 minus 5. Then you get negative 8 plus 16 minus 5. 8 minus 5 is 3. So since our y value is 3 and our x value that we plugged in was 2, our coordinate for our vertex is 2, 3. So what next? Well, one way to do this problem is to start with your graph. We know our axis of symmetry is at 2, so we can draw a dotted line. So we know the symmetry happens right here. That means a reflection will occur on x equals 2. Remember that the vertex should be on the axis of symmetry, and because we plugged in 2 to the x value, we found that the vertex is 2, 3. So 2, 3 is right here. It's your vertex. We'll label it vertex. And if we look at a equals negative 2, we should know that the shape of our quadratic function will go downwards because our a value is a negative value. Since we know the vertex, now what we want to do is find the other points on our graph. So to do so, draw a t-chart. Now I'll draw the t-chart right here. I usually put the vertex right in the middle. So since our vertex is 2, 3, it's right in the middle. And then I asked you, and then the next part of the direction is subtract 2 values of 1. So 2 minus 1 is 1. So just 2 numbers before 2, and then 2 numbers after 2. Basically, to recap from our notes, this is x minus 1, and our x is 2. And then this value right here is x minus 2. Here, this is x plus 1, and x plus 2. So that's what it means. Just find two values before the x value and two values after the x value. What we're going to do now is plug it in to find our point. So the first point we're going to plug in is 0. So y equals negative 2 times 0 squared plus 8 times 0 minus 5. X equals 0, y is negative 5. Okay, next one. Y equals negative 2. We're going to plug in now 1. So 1 squared plus 8 times 1 minus 5. Y equals 1. So we noticed the increasing order. So if we were to think about it as mirror, then we know that now, because 3 is now our highest point, now we know we have to go back in a different direction. So to continue, now we're going to plug in 3 for x. Y equals negative 2 times 3 squared plus 8 times 3 minus 5. Y equals 1. And our last one. Then 4. Y equals negative 2 times 4 squared plus 8 times 4 minus 5. And look at that, it's negative 5. Notice a quick check is because we start from the vertex, our y values match up as we pan out because it's a mirror. So as you graph these points, 0, negative 5 is right here, 1, 1's right here, 2, 3 we graph, 3, 1, and 4, negative 5. We see a parabola shape, and we draw arrows down. So this is our graph. And then we want to label. So we know our axis of symmetry is on the vertex. So our axis of symmetry is x equals 2. That's our axis of symmetry. And then we also notice that this is our highest point, and we call the vertex max. And you can also further say max is at 3, because the highest y value is at 3. And if you want to label your intercepts, we know our y-intercept is right here, which is 0, negative 5. And we actually don't really know our x-intercept, so for this one we could leave it blank. But this is our graph. As you can see, we went through a step-by-step. Slow and steady will win the race. But this is how you do it, and try your next problem on your own. And I hope you check your work by using Desmos after.